4, breaking down problems. Our aim is that students will be able to break down a multi-step problem into 2 parts. So you are going to have problems that involve these formulas, except instead of just inserting and trying to figure out for one variable, instead what you're going to do is have to do a little bit of thinking, splitting the problem into 2 parts. So here is our first example. We have a triangular prism here, and we're asked, what is the volume? So if we just use our regular formula of figuring out what's the base right here times the height, we're going to get this right. We're going to work this out. This number here is 12. However, we need to do a little bit of work to figure out the area of this base. Because right now we know this side, but we don't know this one. So our first step here is to do the Pythagorean theorem. To find out this missing side. So we can do 12 squared plus b squared equals 13 squared. And that's going to give us the missing side that we need to know to eventually calculate the volume here. All right. So we have 144 plus b squared equals 169. We're going to subtract 144 from both sides. We're going to get b squared equals 25. B will equal 5. All right, so I'm going to put that information in over here. And to actually simplify things, I'm just going to scratch this out. We don't need that anymore. That's not going to factor into the area of this base. All right, so now for the second step. The volume equals the area of the base times the height. So our volume is going to equal 12 times 5 times a half, because it's a triangle here, times the height of the figure, which is 8. 12 divided by 2 is going to be 6. 6 times 5, 30. 30 times 8, 240. I'm going to check to make sure I put in my right label, meters cubed, because it's a 3-dimensional figure. So again, there's going to be some times where you're given a couple pieces of information. You're going to need to use the Pythagorean theorem to figure out a missing piece, and that missing piece will help you solve your formula. All right. First example, we're going to do 2 more. This next one, you're going to be, again, using the Pythagorean theorem. So we have, what is the lateral area? All right. So on here, the formula for lateral area is capital L. We're eventually going to use this, so I'm just going to put it down here. It's capital L equals pi r cursive L. Cursive L means the slant height. So cursive L is this missing piece right here. So right now we don't have enough information to use this formula. We are missing a piece from this formula. We have the radius, pi is pi, we need to figure out the slant height. So we have to back up, we're going to have to figure out the slant height. The way we can figure this out, again, we have a right triangle, so we can use pi r squared. And again, this L, this slant height, means how long this is. So we can say L squared equals 6 squared plus 8 squared. So we have a right triangle here. So L squared is going to equal 36 plus 64. L squared will equal 100. So that means that L equals 10. 10 times 10, 100. Now we have enough information to use this formula. So capital L, which is the lateral area, equals pi times the radius, which is 6, times the slant height, which is 10. 6 times 10, 60. pi. Because we're talking about area is 2 dimensions. Area is measured in squares. So we are going to have as our label meters squared, or square meters. So again, we're given some information, but it's not enough to actually use this formula, so we have to back up to find the slant height using the Pythagorean theorem. Many of these multi-step problems are going to ask you to use the Pythagorean theorem. Be ready to use it. Last example. You're going to have an example of a complex 3D figure. It's a more straightforward example of breaking a problem into 2 parts. So on here, this question asks, what is the volume? And there's no formula that's going to solve this complex shape. Not really a set formula on here. So we're going to have to break this problem into 2 parts. The volume of the cone, and then the volume of the cylinder down here. So let's start with the cylinder. So that volume is going to be the base times height. The area of this base, 7 is the radius, so it's going to be 7 squared pi r squared times the height of this cylinder, which is 2. So we have pi times the radius squared times 2. 7 squared is 49. 49 times 2 is going to be 98. So we have 98 pi. 98 pi is going to be the volume of this cylinder here. All right. So volume of the cylinder, next up we got volume of the cone. Volume of the cone is going to be 1/3 the base times the height. So this is pretty easy because we already did the base before. So volume equals 1/3. The area of the base in here is the same for this cone as it was for the cylinder. So I'm actually just going to jump ahead and put in 49 pi. Because the radius squared, 7 squared, times pi, 49. Times the height of this cone, it's going to be 9. So this volume is going to be 1/3. I'm going to simplify this. 9 divided by 3 is 3. 49 times 3 is going to be 47 pi. Okay. So the volume of that cone is 147 pi. The volume of that cylinder is 98 pi. We got to add those together to find the total volume. So we're going to add them together, and we are going to end up with 245 inches. We're talking about volume, 3 dimensions, so we're going cubed. Right? So again, as you look at these problems, especially the ones that are extended responses, you should be thinking about how you can take these complex problems and break them into 2 parts. Whether it's 2 different simple shapes, or whether you have to start to look at using the Pythagorean theorem to figure out missing sides like you had to here, and like you had to on the first problem that had to do with Pythagorean theorem, where they gave you the hypotenuse, they gave you one leg, you had to find that missing leg. Again, they give you these complex problems, you should be looking at how you can break them into 2 parts.